would like to introduce myself. I'm a PhD student. I'm working in Wrocław University of Technology in Poland. And my PhD is based on mathematical models for describing the anterior part of the eye. And ESP is one of my, is my main tool of work. And today I would like to explain to you a little bit what's the technology behind it. You can come closer if you want, because I feel you very far away. The first thing that I would like to tell you, and that's very important that you have in mind, is that the ESP is a profilometer that it's able to pick a really big area, a really big range all over the eye.
Tell me about
Okay, much far away from the limbus. Basically, it's composed by a digital camera and two projectors. Okay, and when you acquire the image, every time that you click the button, let's say, there are two big flashes in just in a fraction of a second, but the person, the patient, let's say, doesn't realize. So it's so quick that doesn't realize. But two different images are created. Okay. Arnold? Okay. This scheme is just to show to you how the images are processed. It's important to know that in the very beginning the images are processed separately, like two different channels. In the very beginning, the first step is trying to reduce some noise from the camera and some masking. Later we need to change to the frequency domain, doing some Fourier transformation. We come back to the space domain. I will explain further why this is needed. And later we merge two channels to one, and what the practitioner gets always is only the 3D map, the 3D height map. Next. Now we are going to analyze. You saw that it's like two rows, two channels, so we are going to analyze one before the merge. Okay? We have this kind of pattern in the eye, so imagine that we select only one row. And we have something like this. This is the information in the space domain from the projected pattern. So the image that the grids that you see here are these grids here. But here, as you can see, I mean, we have nothing there. It's really difficult to extract information from something like this. So that's why we need to change to the frequency domain. Next. Okay. See? This is the space domain that it doesn't tell us much, but if we change to the frequency domain using the Fourier transform, the spectra gets much easier, even though it's not straightforward and it's not something obvious, but it's much easier to analyze the information from here. The peak in the center gives us important information, but somehow residual. That it's not very important. It's not very related to the shape of the eye. Here is where the carrier frequency is. Carrier frequency means that it's the information, is the frequency that really has the information that we really need. So selecting this, let's say this box that is here, is the most tricky part of the whole process. Knowing exactly where is the information that we will need. Next. Okay, and now, once we are happy with that, we know where is the information. We bring it to the middle of the spectra. This process is called the modulation. Next. Okay, so once we are happy with the frequency domain, we know where the information is. We go back to the space domain because it's where we can understand the data. It's it's what we are used to work with. Next. But yeah, as you can see here, it's like, okay, this doesn't give us much. It's a space domain, but still I don't see here any kind of shape. So that's why we need to unwrap the image, and this unwrapping means that it's like it was a kind of puzzle that we need to put these pieces in the correct place. And we get something like this, which is much more, let's say, familiar. Next. So if we are able to do this for every single row, remember that in the very beginning I select a red line, but if we do this for every line, we are able to reconstruct a 3D height map, and this is what we have. Next. And for finishing, well, I start saying that the really nice thing about this device is the big coverage range that it has. So I would like to point it again. With this draw, you can see the different technologies that we are using for profilometry. Here with the ESP, we are in the biggest range. This kind of this Fourier profilometry allows us to go beyond 18 millimeters. And well, you know, this topographer is able to get all the parameters that the normal topographers pick, like the SIMK, the refractive power, asphericity of the cornea. But another thing that, in my opinion, is pretty cool is it's a system which is open. That means that the map that we were saying before, the device, if you want, gives you the X, Y, Z data, and if you want to process it on your own, you can. So you have the information from the device, but you also, I mean, if you have, let's say, computer skills, you also can do with the data whatever you want. I mean, for me, that's really good. I'm working in the university, so we are doing research, so for us that makes an important difference. I've been over 2 years by now working with this device, and I'm quite used to it, quite happy with it, so I will be here around. So if any person wants to make me any question, maybe about the technology or about how to use it, what's the best focus of the image or whatever, I will be happy to reply any question. So that's all, thanks.